In section 7.1, we learned how to interpret the area under a normal curve as both a proportion and a probability. So remember, we had this problem here where we had the giraffes, 2100 was here at this vertical line over here, and then the area to the left was 0.3085. And then the question becomes, how do we find that 0.3085? I mean, I gave it to you in section 7.1, but there must be a way to find it, to find that area, to find that probability. And the answer is there is. It's in section 7.2. Now we're going to use this curve here. The normal density curve is actually this function right here, but that's a very, very complicated function to work with. So we're not going to work with it by hand. You would actually need Calc 2 to do this by hand, Calculus 2. And quite frankly, it's so difficult that most Calculus 2 courses don't even cover it. So we're going to use our calculator instead. So no calculus required. And we're going to be able to find the area under a normal curve with that calculator. And I have all the instructions here, but we're going to see how to do it as we do our examples. All right, so we're going to start here. We have x is normally distributed. We're going to find the probability. That's going to be an area under our curve, recall, from chapter 6 and 7. So we want to find the area under the curve. Now the mean is 20, and we want to find the probability that x is between 19 and 23.5. So greater than 19, but smaller than 23.5. So my plan is to draw 20 down the center of this curve, put 19 over on the left, 23.5 over on the right, and shade in between. So let me draw that 1 second. All right, there I have the picture. So 20 goes down the center. You put that as your mu. Then you put your scores of 19 and 23.5. Technically, both of those are x. Let me label them as such. There, and I labeled it as mu in the center because that's where your center is. That vertical line, it's not drawn in there, but there's a vertical line going down the center of the curve. That's your line of symmetry. It's your mean. All right, so I want to find this area, and I need to state my calculator entry. Now the calculator entry is going to be what I put into the calculator to find this, and that's going to be using normalcdf. So the way normalcdf works, let me just show you from the decision matrix in the back of chapter 7. Actually, let me grab it from a different place. 1 second. There at the end of chapter 7.2, actually, let me scroll down so you can see it in the notes. There it is. It's this part right here, but that's sideways, so it's hard for us to look at as we look at the screen. So I have it right here as well. Okay, so we have values given to us, scores, right? And so we want to find the area of the probability. We're looking for the probability, so we're going to use normalcdf left, comma right, comma mu, comma sigma. Okay, so let me grab the notes again. Scroll back to where we're going. So it's in the notes, but it's also in the exam notes packet. So you don't have to memorize it. You don't have to put it on your note sheet. It's going to be given to you as you do your exam. So don't stress about that. Sorry, I have to scroll back up through this. There we go. Okay, so we want to use normalcdf, left, comma, right, comma, mean, comma, standard deviation. That's what it said in the decision matrix. So right here. Okay, so now what is that? So that's going to be normalcdf. Now look at the left-hand edge of what we shaded. Well, that left-hand edge is that black vertical line. That's 19. And the right-hand edge is 23.5. The mean was 20. The standard deviation was 2. And that's going to give us a value of 0.6514. I'll show you where that is in a second. I just want to make one other quick comment. Your standard deviation is 2, right? And 19 is only 1 away from 20. Since I'm drawing the curves for you, I'm going to get very much on your case about labeling correctly and placing your bars where they should be, more or less. So you should know, hey, 19 is only 1 away from 20. So that means that, here, I'm going to leave this as question mark. So since 19 is only 1 away, I should not put it at a full standard deviation away. I shouldn't get to the inflection points. You should be to the right of the inflection point, but to the left of the center. In other words, your 19 should be right about where I drew it. By the same token, 23.5 over here is more than a standard deviation away, but not quite to 2 standard deviations away, because 2 standard deviations away would be 24, and we're only at 23.5. And I will get on you about putting them in moderately the appropriate place. At the very least, you should know, is it past a standard deviation or before a standard deviation, right? Because that standard deviation is that inflection point where the curve gets as steep as it possibly can, where it stops being concave down and starts being concave up, which happens about a little bit above halfway between the top and the bottom of the graph. All right, so you have to label this. There is nothing on this picture that you can get out of drawing, right? You have to say X is 19. You have to say X is 23.5. You have to have them placed appropriately. You have to have the area labeled as area. Leave it a question mark because you don't know what it is until you find it. And then the mu is the center, right? That's your mean, which is the vertical line going down the middle of your graph. All of that picture has to be drawn. Then you have to state this calculator entry fully, and then let me show you how I get it. So I go to second distribution, and we will always use normal CDF. We will never use normal PDF. Normal PDF is not used for this course. So I'm going to grab number 2, normal CDF. The lower hand bound was 19. The upper hand bound was 23.5. The mean was 20. The standard deviation was 2. So I go down to paste and press enter. And it pastes it in. You have to press enter again to get 0.6514, which is what I said it was. So that's the answer. Now we're going to do it again. So for this one, the mean is 75, the sigma is 8, and I want the probability that X is greater than 90. So let me draw you a picture for that. All right, there we have it. So the mean is 75, and I've labeled that mu 75 in the center. Over here, I have my X value of 90. That's where that vertical line is. And then the area is what I'm looking for. I don't know what it is. Okay, so again, I'm going to need normal CDF, and it's just a question of what to what. So the left-hand edge of what I've shaded is where that vertical bar is at 90. So that's pretty easy. It's 90. I know that the mean and the standard deviation while I'm on the subject are 75 and 8. The question is, what's the right-hand edge? Right? Well, actually, there's a couple of questions. One, notice that 90 is pretty far away from 75 because your standard deviation is 8. So you figure 75 plus 8 gets you 83, 83 plus 8 gets you 91. So it's right around 2 standard deviations away, just a little bit less. That's why it's out here in the tail. You wouldn't want to put 90 really close to the 75, and you don't want it to be too far away. Again, I will get on you about placement, right, of your values. So place it appropriately, more or less. Okay, so then the question is the right-hand edge. So this curve goes on forever and ever and ever. If you remember, we said back in section 7.1 that it's a horizontal asymptote. So it technically never stops. Just real quick, I popped back here to section 7.1 so you could see the properties of the normal density function, and you'll see it goes on forever, and it says the x-axis is a horizontal asymptote. It never touches the x-axis. The curve never touches the x-axis. All right, so I'm going to go back to my question right here. So I need something that'll represent going on forever and ever. Here, let me move this out of the way for you guys so you can see. How can I get forever? Well, the true answer is infinity, right? It goes to infinity. It goes forever. But the problem is there's no infinity button on a TI-84 calculator. You can't put infinity into it. If you were in calculus, you could, right? So we need something else, something mechanical, something a calculator can handle. And the solution to that is scientific notation. What we do is we use 1E99. Now 1E99 is going to stand for 1 followed by 99 zeros. Let me just show you what that would look like for a second. 1E99 is 1 and then, right, 99 of these things. So it's really, 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 really huge. It's way bigger than that, but I just got tired of pressing the 0 button, right? So what you're doing is you're having it stand in place of infinity, right? So, and I put it on the decision matrix at the bottom. Actually, I shouldn't say I did it. Technically, my husband did it. He's the one that had the idea, right? So we have X values. We want the probability, so we're using normal CDF. And then look what it says down here at the bottom. It says if you have infinite bounds, which you would for this one, use either negative 1E99 for the left side or positive 1E99 for the right side. And that's the one we're doing, right? The right-hand side, because we're going to forever on the positive side. So we're using 1E99. Now you got to be careful with the E that you use. So let me show you which one it is. So I go to second distribution, number 2. My right-hand side, or excuse me, my left-hand side was 90. And now I need 1E99. So I type 1. E is scientific notation E. It's above your comma button. So if you look at the comma button, it says double E. They do that because they don't want you to get confused with the alpha E, which is above the sign button, S-I-N button, right? That's alphabet E, like E for elephant, like if you wanted to type text messages to your friends on a calculator, which why we would ever do that, I don't know, but that's what you would do. So instead, you want to use the blue button, second, comma. And the E actually looks a little lowercase. Let me just type both of them so you can see. Capital E, E for elephant, is larger, right? That's actually the letter E, which isn't what you want at all. You want the kind of block letter E that's a little bit smaller. And that's what happens when you hit that double E button above your comma, right? That's scientific notation. It means 1 followed by 99 zeros, essentially. 1 times 10 to the 99 is technically what it means. All right, now my mean was 75 and my standard deviation was 8. So I'm going to go to paste and press enter, and it finds it, 0.0304. Simple as that. And realize how great this is. This is the calculator doing some very heavy mathematical lifting for you, right? Because unless you've taken calculus, actually Calc 2, you can't do this calculation on your own, right? You need a calculator to do it for you. Okay, for this next one, I wanted to prove to you where the numbers came for our giraffe problem from a page ago. So let me scroll back up to it real quick. If you remember, we had this giraffe problem right here. I had 2100 and I told you at the time that the area was 0.3085. So now I want to prove it to you that I wasn't lying. So, and that's what we're going to do by using normalcdf. So let me flip back a page to what we were working on. Okay, fine, 2 pages. All right, so we want normalcdf again, so that's going to be just like before. And we know that the mean was 2200. We know that the standard deviation was 200. And the question is, what are the left and right bounds? Okay, so when we look at what we shaded here, let me push this over. The right-hand edge isn't hard to figure. The right-hand edge is 2100, right? Because it's that black line right there. But the problem is the left-hand edge. So the left-hand edge goes forever to the left, right? So we need to use -1 E99, right? Because it says so, first of all, in the decision matrix. It's standing for negative infinity. It's standing forever to the left side. It's an infinite bound to the left side, so you're going to use -1 E99. It's right here at the bottom. Okay, so let me go back. So I want to type -1 E99, and I'm going to have to find what that is with my calculator. So let me go to normalcdf, which is number 2. Now be very careful. You want to use the negative symbol. It's a little higher and a little smaller than the subtraction. Subtraction looks like that. It's a kind of a big dash in the middle. You want the little subtraction one, which is the parentheses one at the bottom of the calculator. So -1, second comma, gets you your E, your times 10 to the, stands for exponentiate if you want to know what it stands for, right? And then we want 2100 here. Then we want 2200 and 200. And then we go to paste, enter, and there we get it, 0.3085. See, I didn't lie to you. It was 0.3085. Now for this last one, we're going to be a little bit tricky here. So the mean is 180 right here, and the standard deviation is 12. So 165 is past 1 standard deviation away, about 1 and a little bit of change. So I put it over here on the left. 200 is farther away because 200 is 20 away. So that's 1.5 standard deviations, a little bit past that. So I made that one a little bit farther. 165 is only 15 away, 200 is 20 away, and the standard deviation is 12, if you recall. But the trick is I want to be smaller than 165 or, and that's a very big or, right, bigger than 200. So because of the or part, that means I'm actually separating. I'm talking about 2 separate tails, i.e. disjoint. Remember that from chapter 5, right? They're disjoint, separated, mutually exclusive. Okay, so I want the area in both tails, question mark. Okay, now I could find the area on the left. I just learned how to do that over here in letter C. And the area on the right, I could do that using what I did from letter B, and then I could add them up, right? Or means to add. But I could be smarter about it. I could use the complement rule. So remember the complement rule is that the whole probability distribution has to sum to 1. So the area under the entire curve is 1. If I could find the white center area in the middle and take it away from 1, I'll know what the two tails are. And that's what I'm going to do. Okay, so the area in both tails, which is what I'm looking for, is 1 minus the central area, or the center area. Okay, so I'm going to take 1 minus normal CDF. Now the question is from what to what? Well, that central area is actually kind of easy to find because it has definitive boundaries. It has 165 on the left, it has 200 on the right, the mean was 180, and the standard deviation was 12. So I'm going to take 1 minus all of that. Sorry, I got to get that little squiggly equals out of there. The approximation symbol if you want to get all fancy about it. Okay, so that gives us our answer of 1 minus, and then I've got to go find that value. So I'm going to do that with my calculator. So normal CDF, number 2. I'm going to say from 165 to 200, the mean was 180, the standard deviation was 12. So that's 1 minus 0.8466. Right? Which means that our result is about 0.1534, but I can do that with my calculator. 1 minus that answer. Second negative gets you that. Also remember, you can actually do it all at once. You can type 1 minus, then go to the distribution, normal CDF, type all those values in, and it'll find it all at once. Right? So you don't have to do it in separate parts if you don't want to, but you can if you feel like it. So it's 0.1534. Oops, sorry. There we have it. And there's our result. So now we know the basics for working with these normal curves for x values and mu's. The problem is that all this was divorced of context, right? These didn't have any meaning to us other than this one, which were the giraffes, because we had seen the context earlier, namely giraffes. So now in the next problem, we're going to actually start assigning context and give these values meaning